mice and keyboards. That is a little bit of a difficult one because the keyboards and the mouse in the computer labs are a little bit, what you perhaps can consider doing is if you've got a wireless keyboard and mouse, then you can just plug in the wireless receiver in the front of the computer. That is an option, but a wired keyboard and mouse is a little bit more tricky to get going. Okay. What if someone knows they have COVID and they still come and write it? Well, they're not allowed to. As easy as that. Okay, awesome. If they've got COVID, then they can get a sick note and then they can write the sick test. Okay, so don't come if you've got COVID, please. I mean, that's just general rules. Don't come to the campus if you have COVID. If you have a peripheral with onboard memory, no, don't do that. We actually do look at that, and that is definitely not allowed. No USB memory sticks will be allowed inside the semester test or exam venues. We are not born yesterday. We actually do check those things. Okay, guys, let's go on. Right, I'm going to share my screen. We are going to talk about the two-dimensional arrays. And I just want to quickly go through this piece of code and again just cover what's going to happen as soon as we run these lines of code. So what we've got in the one line of code, we've got some kind of variable that stores, let's say, 5 numbers of items, 5 integers. Then we've declared a one-dimensional, a pointer to a one-dimensional array, and we have created some memory allocated to this. Now remember what happens in this case. As soon as the computer runs this line of code here that says int star array nums, it basically goes into memory. It assigns a memory location, and as soon as you go to new, it basically goes and initializes that value to a memory location, and it basically, in this example, creates 5 different memory cells. How many I've got there? 5. There we go. Let's try again. Why does it not want to do that? There we go. 5 of them. There we go. Boom. All right, and that is a one-dimensional dynamic array. We've covered this already. Now consider this. Let's assume we just take that out for now, and we rename this thing to array nums, and we make another one, array nums2, and int star array nums3, and below each of these we have our array nums. 1 is new int count. Right, let's just make a copy of that. And then here as well. Now, when we do this, can you see this first line created this little item? And if we go to the next line and we execute that, that also creates a new memory location, and that also creates a new memory location. Each of these are pointer types, remember? And as soon as we create these new or execute these new instructions, it creates these what we call anonymous variables. So it goes and creates one for that and another one for that. It's easy as that. And obviously each of these are now a different color. So can you see with 3 one-dimensional arrays, we have effectively created, does that look familiar? I hope you can see that that looks familiar. That looks like a 2-dimensional array. Now we're going to use the same principle method. Now instead of having create 3 named pointers like these, what we're instead going to do is we are going to basically create a different, we're going to handle this in a different way. So let me see if I can demonstrate how we're going to do this now. Let's get rid of that. Boom. All right. Okay, so now let's assume we declare a new variable type. Now, instead of this variable type showing that it is a pointer to an integers, we create a variable type that says it is a pointer that points to a pointer that points to a number of integers. So let's just quickly see what happens when we do this. As soon as you create this, again, we're going to create a little block like that. And when we are then going to allocate memory to it, so we're going to have to do something like this. Array nums1 is new. Oh, new what? We can't have it in new integers. So instead, we're going to say, hold on, we're going to now create or let it indicate to a new number of integer pointers that we're going to point it to. Now, in this case, how many of them? So initially, we said, okay, that was 5. Let's just move that one up. Let's just say those are the rows. Actually, that's the columns. And then this is the rows. And we say that that is maybe 3. Then we can say that that is a row number of them. But let's see what happens when we do this. So basically, we're saying that we're going to create a pointer type, a memory for a new pointer type, that will also point to a number of integers. How many of them are we going to create? Well, we're going to, in this example, create 3 of them. So let's go and create 3 of these things. In fact, let's just take that and let's just do that. Boom. All right. And then we have to go into each one of these and declare memory and or allocate memory for each one of these as well. So now we're going to go into, in fact, we're going to have to create a little loop here. And let's just say n equals 0 while n is less than the number of rows. At each round, increment n, and then in this case, go array nums of n is new int. How many of them? Int columns of them. Okay. All right, so let's have a look. So first we created a number of rows. That was a syntax error there, number of rows. This created these 3 ones. And as we go into each of these, they in turn will also point to a number of memory allocations. And they will be 5 in size. 1, 2, 3, 4, 3, 4, 5. So we do that for round 1. For round 2, the same thing happens. And for round 3 as well. And that is how we create a 2-dynamic array. So let me just quickly see what are some of the questions that we have. And then we'll go through this again very, very slowly. Okay, so firstly, is there a difference between int star, int me, and int star, int me? So Mr. Shibambu, what's the differences between the ones that's got spaces in? No, there's no difference between them. Good afternoon, Professor. Hi there. Is it possible to create a normal array? And for its size, we create a pointer of an integer type, wherein we can just configure its size when the programs run. No, you cannot, because normal arrays is always fixed size, even if they have pointers in them. Well, a normal array can still point to pointers, but then you still have to initialize those pointers to a specific size, but then you will not have a 2-dynamic array function. It will just be a bunch of one-dimension array. The one dimension itself will always be a fixed size. What is the difference between int star and int star star? Okay, so int star is a pointer to an integer. Int star star is a pointer to a pointer that points to a number of integers. Can you see the difference here on the screen? Int star star, look at the number of yellow items that we have here. Imagine this is the first star. and that's the second star, and then these ones are our integers. Maybe that's one way to visualize it. Okay, so it's int star star is a pointer to a pointer type to a bunch of integers. That's what int star star means. A normal int star is just a pointer to a number of integers, which is exactly that thing. So we've basically created a two-dimensional array by creating a number of one-dimensional arrays in it. Now I minimized that. That's not what I wanted to do. Okay, let's get back. Why don't we just write star n++ instead of n++? You can't dereference a non-pointer. Okay, so the question Mr. Nju asks, in the for loop, the n variable created there, okay, that's obviously a spelling a syntax error that I made there. That's supposed to be equal to 0. That n is not a pointer type, so you can't dereference it. So you can't now suddenly in here put a little star in there. That's impossible, because that data type is not a star, it's not a pointer. It's a normal integer like we've had in any of our previous lectures that we've discussed. Okay, so that's why you can't use a star n++ syntax there. Okay, next. That's not what I wanted to do. Is it n equals 0? Yes, sorry, that was my mistake. So we are creating an array of pointers at each point to a pointer array. 100% correct, Mr. Milne. Yes, okay, Mr. Lamini helped us there. So what is the point of using pointers? I think we've discussed this in the previous lectures already. It helps us to create these dynamic arrays at the moment. Without pointers, you cannot create dynamic arrays. You will also see in the next semester, without pointers, you can't really work with classes very well. And it's much more difficult to use classes in different types of functions. So you said that int star star array nums1 because it is a two-dimensional, or? Well, it is a two-dimensional. It's actually a pointer to an integer. We're using it as a two-dimensional array, Mr. Kortjas. What is the differences between array nums n and array nums? Array, okay, I assume, Mr. Govender, that you're talking about that and that. Sorry, that should be array nums1. I hope that makes it a little bit more clearer. But effectively, that does this. It does this portion of it. So basically, as soon as you say array nums1 equals new int, there's actually better ways of writing this, and I'll explain it to you just now. That's why we use type definitions. It basically will go and create a number of pointer types. How many of them? Well, row numbers of them. In here, we basically go into each of these pointer types, and we're saying you now point and allocate memory to a number of memory locations. That's what happens in this line of code. Ah, man, I've minimized that all again. Okay, see. Are you storing data inside the data? No, we're storing data inside an array. I don't know if data is the right word here. So data is 100% correct. You can use data, and we can store data inside an array. You're 100% correct. That's what we do here. Variables store data. It doesn't store code. So yes, we use this to store any kind of data that we need. Taking this further, would it be possible to make a three-dimensional array? Absolutely. You can take each of these, instead of integers, memory locations, and you can create those as also pointer types. And then you've got this three-dimensional array effectively. But, I mean, we're not going to go that far in Computer Science 1A. What is the restriction to the number of pointers you can use? And if you can use more than 2, why would you use 2? Under what circumstances will that be required? Okay, so, right, this is just my timer that informs me that I need to share. Okay, I'll answer that question just now. Just quickly for those that's going to watch this recording at the later stage. This is the code that you're going to have to type for the late viewing register. Wait for it. There we go. That is the code for the late viewing register. Thank you very much for those that's watching this recording at a later stage. I think this is long enough. You can pause here if you want to. Let's get back to the actual questions. So the question was, what is the limit? Well, the limit is the heap size. It depends absolutely on the memory that you've got on your machine. It also depends on whether you're writing a 32-bit or a 64-bit computer or program. Each of them has a specific memory size limit, and basically the amount of memory that you have available in your computer, that is the limitation. Why would you want to use a two-dimensional array instead of just a one-dimensional array? Well, I think for many different reasons. For two-dimensional arrays, the way that we're going to use them inside Computer Science 1A, as described in the tutorial that I have published already yesterday, but you guys can have a look at it, is we use it for game-based purposes. So we create two-dimensional worlds that sometimes is a map that you watch from a bird's eye view. Sometimes we watch it from the side, and we can create different things in this two-dimensional array. And that's why we want pointers to pointers. What does new do? This has been covered in previous lectures, Mr. Musaro Urwa, but effectively it allocates memory to a specific variable. Will I be wrong to say that new int star star row? Mr. Korchas, that depends on what you want to do. That will definitely not work because you don't know exactly which pointer. No, sorry, Mr. Korchas, that will not work, what you're indicating there. Because you have to describe which number or what you're basically going to create. I'm not even sure if this syntax of mine is 100% correct. I'll show you now what is a much better syntax that we're going to use. Will we be using pointers with multi-dimensional arrays? Absolutely. Battleships, definitely. Won't it say array nums is not declared? Okay, spelling mistake. Yes, it will say that, because it has to be 2 R's. There we go. Guys, I'm not writing in code blocks here. I'm trying to explain principles. Geez, like, don't look at the actual syntax now. Okay, so let's look at a little bit about how do we work with syntax and how can we actually define this a little bit better. Now, what we normally would advise students to do is when we declare and define one-dimensional arrays and two-dimensional arrays are to use type definitions. So you've learned that a one-dimensional array can be declared like this. You can say int star, let's say type one-dimensional array, something like that. Now we can declare this as a type definition. So type definition, int star, let's say 1D array, something like that. So that means now, instead of when we use one-dimensional arrays, we can use 1D array, the word like that. And we can do the same for a two-dimensional array. We can say int star star is maybe something like this, 2D array. So this creates an alias for a two-dimensional array. Now when we declare a variable, instead of having to remember how many stars in front, and remember you're going to pass these variables to and from functions quite a lot, it is better to use the alias that you've just created. So just say that this is a two-dimensional array. And instead of you saying that I'm going to create a new int star number of rows, all you say is I'm going to create a number of, because these are just one-dimensional arrays, you say I'm going to create a number of one-dimensional array types. How many of them? Well, what did we say? Column numbers of them. Sorry, row numbers of them. There we go. As soon as you do that, can you see it reads a little bit cleaner because you say I'm going to create a new, what am I going to create? New one-dimensional array of rows, because this is, we've declared that that's just a one-dimensional array. That's just a one-dimensional array. That's just a one-dimensional array. How many of them am I creating? Well, row numbers of them. In this example, 1, 2, 3 of them. And then I go into each of these one-dimensional arrays, and I then create individual allocation memory for them. Okay, so that's why we recommend that you rather use type definitions. It just makes the syntax a lot more simpler. Okay, so this is the theory. Now remember this little picture. So it's a star that points to a star. And each of these guys are allocated memory. And then these are also, they all point to a one-dimensional arrays like this. Now let's see how this is done in something like real, something like code blocks, where we've got real code now. So let's have move to that location. I'm just going to stop this. Okay, so what you see on the screen is basically what we've done previously is showing you how a one-dimensional array allocation works. Okay, so what this was, in fact, a few lectures back. We asked, how many students do you have? We said we had, let's say, 10 students, and we created an array where we can store these 10 students, their, let's say, marks or whatever. Okay, now let's see how we're going to do this with a two-dimensional array. So I'm going to get rid of that, and I'm going to get rid of this function. Even though we're still going to have a delete array, let's keep the function names there, because I think they are useful. And we're going to this function. Well, let's get rid of that. Do it from scratch. Okay. Right, so let's have a look at, we've already said that type definition int star is a one-dimensional array, and then that is maybe a two-dimensional array type. Okay, type 2D array, let's just make it a D in there. There we go. I think that is maybe a good start. Can you see how it's a new alias that defines a one-dimensional array, that defines a two-dimensional array, and what I'm going to do is I'm going to ask this, the user of the system, let's say, I'm declaring it rows here, it's columns, and then I'm going to ask the user for how many rows and columns, and then columns, I'm going to read it in the first rows, and then into columns, something like that. Very, very simplistic, just getting two inputs from the keyboard. I'm not going to go into the details of testing whether this is actual integers. I'm just trying to explain that this is dynamic variables, meaning their sizes can change. Every time we run the program, their sizes differ. So again, as a general rule, I'd like to go ahead and just compile it at that point in time. Now let's go and declare my two-dimensional array here. So it's a, what did I say? It's a type 2D array, and I'm just going to say array world, because it's, let's say maybe it's a grid of the two-dimensional things, and I'm going to put my variables in this two-dimensional array. I'm going to create a variable here called array world. Let's see, there's a question, I think. I think someone's hand was up, but their hand is now down. Okay, so as soon as I do that, the first little box in the Excel spreadsheet that you saw basically gets created. So let's just to help me, I'm just going to share the whole screen here, because then it will be easier just to move between the two different applications. You don't have to put in an end line. Why do you want to put an end line there? Okay, so basically that creates this little box. Forget about all of this code now. Okay, it creates this little box. Let's clear out these boxes as well. So it creates that little box, but it's not colored in yet, meaning it's not pointing anywhere. In fact, it points to some weird location. All right? This is what happens as soon as you do that. Now we're going to have to initialize this variable to a proper two-dimensional array. So let's create a function that will do that for us. So this function will return a type 2D array, because we can do that with dynamic arrays, but it's not possible to do this with fixed size arrays. So I'm going to say init world to initialize the world, and I'm going to need the number of rows, and I'm going to need to know the number of columns. I'm going to so that I can understand how big the world is going to be. Okay, let's just quickly see. There was a question. Thank you for the lesson, Professor. It's a pleasure. What did it say? Array nums not declared. Are we prompting the user? Don't we end line? It's not always necessary to put an end line. I'm just going to prompt immediately next to the prompt. So that's okay. Right. Let's have a look. Next one. Now we're busy in the init world. So now we have to take this thing further. We are going to have to say you are now going to point to a number of these little boxes. So how do I create these little boxes? Let's just make them yellow again. And for that, I'm going to say, well, first let's just declare a 2D array here. So this is array world, because this function will return that. What I always like to do is I like to declare that type of variable, and at the end, I would like to then return array world. Now that it's declared, let's go create that first little pointer. So array world is equal to new what? A one-dimensional array, because that's exactly what it is. It is a one-dimensional array. A one-dimensional array, how many of them? Int rows of them. Okay, as soon as you do that, then this little pointer will point into that location. This one is now a yellow color, indicating that it is now initialized, meaning there's an actual value in here. These values, they still all point in all weird directions all over the show. Okay, so they are all still there, if you want to think of it like that. But these three little boxes, they are now created. Now, how do I go into each of these three little boxes? Well, I do that using a for loop. So basically, I declare a little for loop that will use some kind of counter, let's say n, and we will start counting and we will count while n is less than the number of columns. And through each iteration, I will increment the count. Then, once I'm in that count, I will now declare the memory, or I will allocate the memory for each of those rows. And to do that, I'm going to say array world n, meaning go to the first one. So that means I'm now going into that first little box. And I'm saying, you little first little box, you are going to point to how many number of integers? Well, int columns of them. As soon as you do that, then this little pointer will point to this location, color it in yellow, and it's going to create these little boxes that's there. Okay, what's inside these boxes at the moment? Well, a bunch of junk. Okay? That's what's going to happen. All right, and this line of code will repeat for, that's incorrect, rows, sorry, for each of the rows that I have. So basically, it's going to start at row number 0. Then it's going to go to row number 1. As soon as it goes to row number 1, this little box initializes and points into the correct location, and boom, it is also now allocated. In the next iteration, this little pointer will point into its correct location, and the box gets initialized. All right, and that's what happens inside this for loop. So basically, this allocates the memory for the 2D array. Get rid of this so there's a little bit more screen space. You're not 100% done yet, because part of variables is not just the initialization of the variable, because that's effectively what allocating memory means. We have now initialized the memory for our 2D array. What is inside this? Well, we're going to have to initialize it to a specific values. Now, to do that, we have to go into each of these array items. So I'm going to just create another separate piece of code here. It's not always necessary. You can sometimes link it into the actual for loop that we have right now, or there on top. But for explanation purposes, I'm going to create it as two separate portions of the code. So this one will basically go through each of the rows, and then it will go into each of the columns. Can you see I'm using R and C in this example just because it kind of makes sense, because we're counting now columns and rows. Then go into each of those items, rows and columns, and maybe give it a value. Let's say we initialize it to 0. So this initializes the initial values of the 2D array. Please have a look at the tutorial that I did yesterday. I'm not sure if the tutors did the same type of things today as well, but the recording on Eve shows how this specific values are allocated and initialized in a specific example where maybe these values are not always 0, but for class purposes, this is what I'm doing now. Okay, so this allocates, this initializes, and then it returns this array world. So basically, if I want to initialize this, all I do is this: init world, int rows, int columns, and that will initialize immediately after this. This variable will now be a 2-dimensional array with a bunch of zeros inside it. That's effectively what I need. That's what we need. Now we're not complete yet. This is sometimes which I sometimes forget, and this is now to deallocate the memory. So I'm just going to create a variable or a function here called, let's say, delete array. I have to give it the actual array, so the 2-dimensional type 2D array world, and again we use the same principle, and this was explained in the previous lecture. We have to pass this by reference, and I need to know the number of rows. Right, so we're going to have to create something to delete that or deallocate, reverse this step to deallocate the memory. Before I do that, let's quickly have a look at the questions that came in. How do I put values in the 2D array? I've just shown you that just now. So basically you have to loop through each of the array code. Let me just show you that again. This is how you put values inside a 2-dimensional array. I'm putting value zeros in there. Okay, first rows and then columns. So are you going to upload this code? I can do that. This is really not that difficult, but I will definitely upload it. So will there be a recording of you doing this week's TUT or not? It's already uploaded on Eve, the tutorial. And compile. Oh yes, and compile. Thank you for that. I love it. This is such a, you are so good. Yes, and compile. I know that yesterday was a public, so I'm just checking. Yes, I actually did already upload the tutorial that I did yesterday. Oh, well, let's call it an anonymous tutorial. I did it on my own, but just for recording purposes. So Dreyer, if you use a function that returns an array, like populates the array with random values, that function in itself should then allocate memory to be able to return that array. Do I have to delete the array that was created within the function, and do I have to delete the array in storing the new values before I use the function? I understand. Okay, so if you use it in this way, so for instance, this case, we created a function that returns an array, and this function itself allocates the memory, but can you see we haven't deleted it yet? It is not necessary for the function itself to delete it, because we're going to use that 2-dimensional array in all of the code that I have. Just at some point you may want to delete it. However, if you have a function, let's say for instance you have a function that may want to move from one state, you have to look at the current state of a 2-dimensional array to create a second state of the game world. In that environment, you're going to temporarily create a 2-dimensional array, and then once you've finished working with that temporary 2-dimensional array, you have to then delete it. Okay. Otherwise, every time you're going to call that function, it will allocate the memory. So that's maybe the rule of thumb is, if you call your initialization once, you have to delete it once. If you initialize it potentially multiple times, you have to delete it for every type of initialization that occurs. Let me just finish completing this code, then I will go through the rest of the questions. Otherwise, we're going to run out of time. So to delete an array, the first thing you do is you first have to go into each of these, let's go to Excel rather. You have to go into each of these little pointers and delete this memory, meaning get rid of them. And the way that you do that is, again, using a for loop. So again, for int n is 0 while n is less than the number of rows, then in n++. And now delete array world what n. Now, as soon as I do that, let's just quickly see what happens in here. Can you see I'm going for each of the rows? So that means I'm starting at this row, number 0, and then as soon as the first line of code runs, or this line of code runs, where I say delete array n, array world n, it goes into this and it deletes it, meaning it basically does that. Gone. Then I go to the next row because I'm counting through the next rows, and then the next row gets deleted. So again, boom, gone. And then the last row, jump, boom, gone. All right. And now I must delete these guys. These are my column ones. So how many must I delete there? Well, luckily you don't have to specify, because with the delete function, you just say this: delete array world, and this will delete the yellow ones. Oh, sorry, man. Delete that. And then, because this thing is still pointing to a memory that it's not supposed to point to, you have to make sure and reset it so that it doesn't become what they call a dangling pointer. So now you just say array world is null pointer or none. That is how you delete an array. And obviously, at the end of the day, before we exit this program, we will potentially have to delete it. So delete array world int rows. That is how you do the code for deleting an array. And in between here, after this, we will use array world for our games or whatever. And then at the end of the day, we have to delete the memory allocated. Now, strictly speaking, this won't do much, but you will be tested on to make sure that you understand how to delete an array. So that's why, please, in this example, when the program exits, the memory gets given back to the operating system anyway. So effectively, this function will run. It will basically deallocate that memory, and the program will exit, and the operating system will take back all the memory anyway. So strictly speaking, that won't do much in the big scheme of things. But because you are tested to see can you actually deallocate the memory again, please make sure that you do include this type of thing in your code when you're working with two-dimensional arrays. Okay, so lastly, let's quickly go through the questions. Our time is up. So the whole grid gets deleted, not just the numbers inside it. It's not that the grid gets deleted, it's the memory gets deallocated. The numbers actually stay in that memory locations, Mr. Govender. So that's why there's always junk in memory, because of old things that we used to do. Sorry, I just want to see, Mr. How do you manually put values into the array as per user input? Is it the same principle as what you did, sir? Yes, potentially. Instead of doing this, you can do a cin. So you can basically say cin, boom. Okay, and that means you will continuously just add numbers. Okay, that is Mr. Klatchman. Why do we need to deallocate the memory? We need to always deallocate memory because potentially if we just keep on allocating new memory, we will run out of memory. Number of columns doesn't matter when deleting. No, it doesn't. Hopefully you saw that. Why not? Please can you explain line 32 again? Line 32. I'm not sure if it's still line 32. Okay, maybe just re-ask the question. I'm not sure what was line 32. Okay, we've answered that. We've answered that, Mr. Milne. So we assign the pointer of a 2D array created in the init world function to the pointer of array world in main. If so, does this mean that the stack memory storing pointers created in the init world function are given back to the OS and therefore no longer exist? 100% correct. Mr. Milne, your interpretation is 100% correct. So the whole grid gets deleted, not just the numbers. Well, I've talked about. So what happens? The difference between for int and for int I. Well, I is less than. I'm not sure exactly, and for, I'm not sure what you mean by -1 and +1. That does not make sense. So, sorry, Mr. Hyperasad. Maybe you can take this offline, maybe on Discord. What happens if I start deleting the columns? Well, if you delete the columns, it doesn't make sense because where are we? Let's go back to Excel. Let's see if we can get all of this back. Basically, if you delete the columns, these are not related. Okay, so you can't say delete this column because this pointer doesn't point to columns. Oh, well, it doesn't point, this pointer deletes the actual array itself, but you can't go and delete that column right there. That's impossible. Let's see. Our time is up, guys. I have to finish this. If you say only delete array world, will the rest of the array still stay there? It will not. So, Mr. Hoffelmeier, it will not delete the memory allocated in this section. So, if you just delete this pointer, basically, if you just delete that, because that's effectively what you're asking. Sorry, I need to do that. If you delete that, then this memory still stays allocated and it doesn't delete it. For semester 2, do we receive the question paper digitally or physically paper? Well, digitally or physically, we're actually asking, we're considering digitally, meaning on the computer screen itself. Do we receive the question? Okay, scribble on paper. Yes, we will give you scribble paper. Okay, guys, that's it for today. Thank you very much for attending. As I've mentioned, the tutorial that I anonymously did yesterday is on Eve.